In this second part of this video series on the meaning of the area bounded by the velocity time graph, we're going to look at a couple of other situations. But again, when you finish this video, you should be able to state what the area bounded by the velocity time graph means, be able to make an argument for its meaning, and determine the area bounded by the velocity time graph. Now let's go ahead and take a look at a couple of other situations. Let's again make a velocity time graph. Something like this. Only this time, let's imagine an object which travels a little bit differently. Let's say it travels 5 meters per second for a while, and then it turns around and travels in the other direction, but just 2 meters per second. Make that axis a little bit longer here. And let's picture this time right here to be 5 seconds. Go ahead and label this as the time axis in seconds, and this is the velocity axis in meters per second. And let's label this as 5 meters per second, and that is negative 2 meters per second. Now, having found out that the area bounded by this graph gives us the displacement, let's imagine we are again interested in what is the displacement of this object. So what is the displacement of this object? All right, well, there are two areas here that we can consider. This area and this area in here. All right, so let's examine them one at a time. Let's call that area 1. All right, so area 1 here is going to be length times width. The length of this is 5 seconds, and the width from here to here is 5 meters per second. That is 25 meters then. So the displacement in that first part of the time, the first 5 seconds, is 25 meters. Now let's look at the second part here. Here the area again is equal to length times width, but we have a different rectangle. And here the length is again, let's say that's 10 seconds there. So again, 5 seconds. From 5 to 10 seconds is a total of 5 seconds. But now the width is, from here to here, is negative 2 meters per second. And so that comes out to a displacement of negative 10 meters during that time interval. Well, the displacement of the object during the whole motion then is the combination of those two, or 15 meters. So the displacement of the object is 15 meters. So the thing that this example illustrates is that when the object is moving in the negative direction, you still have an area, but it's sort of a negative area. It's a negative, represents a negative displacement. All right, let's take a look at another example here. Let's assume the object is no longer traveling at a steady speed. There's our time axis. There's our velocity axis. Let's say the object is speeding up. And let's say the object speeds up to 5 meters per second but starts at 0. Well, now, up to that point, let's say that's 7 seconds. Now the area that we're interested in is no longer a rectangle, rather it's a triangle. But the meaning is the same. The area is the displacement, and the area then for this shape is 1/2 base times height. Let's make that better. Base times height. All right, and so 1/2 base is 7 times a height of 5, and so here we're going to have 1/2 of 35, or 17.5 meters. And so in this video you've seen two different sorts of area under velocity time graph shapes, and this should give you enough guidance to explore any area under any velocity time graph.